Welcome to the last question, problem number 36 from the January 2016 Geometry Regents exam. This is a pretty lengthy question, so long story short, we are trying to find the height of this flagpole. You're going to be using some trig ratios to help us out. Now the problem is that although we do have some right angle triangles here, we don't know any of the full distances, but we do know the distance from here to here is 8, so we can use that to help us a little bit. Now let's label the height of the flag h, and let's also label the distance from here to here as x. What that means is the distance of this larger triangle would be x plus 8, because we would just add that distance there. So the strategy we're going to use is that we're going to set the tangent ratios of each triangle equal to each other, and then we'll have an equation where we can solve for x, and then from that, then we can find out the height of the flagpole. So quite a bit of work to do. So let's start off by looking at the tangent ratio of the angle 52.8 degrees. So the tangent ratio is opposite over adjacent, so our opposite distances are h, and our adjacent side length is our distance that we labeled as x. Now it's going to be helpful to manipulate this formula to isolate our height, h, and you'll see why we're doing that in a minute. So to isolate h, we're going to multiply everything by x. So h would equal x times tan of 52.8. Now let's take a look at our tangent ratio for the other angle that we know. We know that tan of 34.9 degrees is going to equal our opposite, which again is h, over our adjacent. Now our adjacent this time is x plus 8. So now if we want to solve for h, it'd be pretty similar as above, but this time we're going to multiply x plus 8 times tan of 34.9. So now what we're going to do is, because we have solved for h in two different ways, the height, we're going to set these equal to each other and solve for x. I'm going to zoom in over here actually, just because we're running out of space. Alright, now the first thing I'm going to do is get rid of these brackets by distributing and multiplying tan of 34.9 with both of those. After doing that, the next thing we want to try to do is move all of our x terms together to the same side. So I'm going to subtract this term in order to move it to the same side as the other x term. Now that we've done that, we can factor out the common term. Both of these terms have an x. So we factor out the x, and we'd be left with tan of 52.8 minus tan of 34.9. Okay, now to completely isolate x, we're going to divide everything by tan 52.8 minus tan of 34.9. Okay, now very carefully typing this into your calculator, this whole thing here will get us our value of x, which rounds to about a value of 9. Now, we're not done yet though. Remember, we're trying to find the height of the flagpole. But now that we do know that x has a value of 9, we can utilize this smaller triangle, because we do know the angle is 52.8. We now know the x distance is 9, so we can use a tan ratio to find out our height. So we'll say tan of 52.8 equals our height over our x distance, which we know now to be 9. So our height we can find by taking 9 and multiplying it by tan of 52.8. And when we type that into our calculator, we get about 11.86. Oh, hang on a second though. We almost forgot about the height of the survey instrument. It's 1.7 meters above the ground. So to get the total height of the flagpole, we just need to add that 1.7 on. Once we do that, we finally get our final answer to the nearest tenth of a meter of 13.6 meters. All right, wow, that was a pretty intense question. I hope that whole strategy and everything made sense to you. And that is it for this video. Thanks for visiting JD's Regents Preparation.